It is a real pleasure to speak with you tonight, and I'm going to tell you a little story that I've been kind of working on for the past decade. And, you know, I hope to convey my passion for geology, for geoscience, because I was very fortunate to kind of fall into it when I first went to university. I just came under the spell of a very top-notch geologist who kind of hooked me on this field of study, and I've pursued it ever since. And the nice thing about geology is you can keep it as a hobby or as a profession forever, virtually. And the more you learn, the better you get at it. So my interests are pretty broad. And tonight I'm going to speak to you about this very amazing story that we've kind of learned about over the past decade. And I'm going to take you back to the end of the ice ages when the last glaciers, the last big ice sheet that covered British Columbia melted away. And I'm going to set the stage for that by actually talking about another big flood that you may be aware of, the Great Missoula floods. But first, I want to convey to you the importance of technology and science. Technology is driving science forward at a breathtaking pace, and all fields, certainly not geoscience alone. All you have to do is look at medicine and CRISPR technology to understand the very rapid strides that we're making in understanding all aspects of the world in which we live, and you know, how we function, how organisms function. One of these tools that has really transformed my field, which is geomorphology, is called LIDAR. And LIDAR it's not really an acronym, but it means light detection and ranging, or some people refer to it as laser imaging detection and ranging. And this is a technique, it's actually been around for over 50 years, but it's only with technological developments that we're able to use it as a tool in geology. And I'm just going to give you a very brief capsule summary of what LIDAR is. Now, LIDAR instruments are active sensors. They basically beam out a swath of light, either from the ground or, as in this image, from an aircraft. And that aircraft and the instrument are precisely positioned in three-dimensional space. So with technology has allowed us to really exactly locate where that aircraft is in the air. And so as a result, when that beam of light, kind of ranging all the way from ultraviolet to near infrared, strikes something on the surface of the earth, it could be a tree, it could be a rock outcrop, it is reflecting that light back up to the sensor. The sensor records it again in three-dimensional space. And as that aircraft moves along, you get a spatial coverage of the whole landscape. You get a cloud of reflected light waves that reach the aircraft. And
John, sorry to interrupt. Are you sharing your screen? Like, are you supposed to be showing us images?
I am.
Okay, we're not seeing the images.
Oh, okay. Sorry about that. Maybe I have to, hang on.
Yeah, you'll need to screen share, which is down at the bottom, or share screen.
Gotcha. Sorry. Can you see it now?
There we go. Perfect.
Okay. So let me put this on. Thank you for that. I didn't realize I had to do that. Okay.
That's perfect.
That's excellent.
Okay.
Excellent.
So I won't repeat what I said, but basically,
Is that like what Google does with Google Earth?
It's not Google Earth. Google Earth is satellite imagery. This is actually a swath of light that reflects off objects on the surface of the Earth. And it creates what we call a point cloud of reflections back to the aircraft. And you can map those out. So as this aircraft speeds along, you get coverage of the whole land surface over which the aircraft is flying. And the neat thing about it is there are millions and millions of these returns, these LiDAR returns, these points. And you can electronically, for a geologist, you can electronically screen out the ones that are striking objects above the ground. So say you get a reflection from the leaf of a tree. You basically screen that out. You selectively pick the returns that are coming last from the ground surface. Everything else gets stripped out. So you might have, say, for a cubic meter of ground, you might have 5 or 10 of these returns. But that's enough to allow you to map out the surface of the Earth without that, and I won't say annoying vegetation cover, but for a geologist, we're interested in seeing the surface of the Earth and letting it tell us what it can about Earth history. So this incredible tool allows a geomorphologist to much better interpret the landscape than we would have been able to do with simply photographs alone. And I'm going to show you an example of how we do that. Now, that's not to say that this isn't a powerful tool in many other fields. I mean, foresters might be interested in the canopy of the forest. So they, rather than look for that last return off the bare ground, they're looking for the first returns and the height of the canopy, the height of the trees. You know, this is a tool that's been used in autonomous vehicles. So you probably are Teslas, they're self-driving. This is based on this type of technology. And it's not perfect because occasionally the Teslas crash. But, that doesn't happen too often. Archaeology, let me give you an example there. 3 years ago, they flew an aircraft over a large area of the Yucatan Peninsula. Now that is forest. It's basically subtropical forest. You can see very little on the ground, but with LiDAR, they penetrated that forest cover and they saw over 60,000 man-made Mayan structures that they didn't know were there. You know, it essentially greatly increased our knowledge, and it still is greatly increasing our knowledge of this civilization. You know, everybody knows about Chichen Itza and Uxmal. You know, they've been basically they've been cleared out of the forest, and they're very impressive. But there's 60,000 of these types of structures covered in forest on Yucatan Peninsula in Guatemala that we didn't even know were there until a few years ago. So that's another tool, another way that this technology can be used. But I'm going to return the focus here to geomorphology, which is the surface of the Earth. It's a science of understanding the surface of the Earth. And the reason I'm doing this is because this flood story is built in part on the use of this technology. So this is an area in central British Columbia. The road at the top there is Highway 97. It's north of Prince George, a place called Summit Lake. And I just pulled this image out just as an example. It could be many other images, but this one really shows the power of LiDAR. So this is a satellite image. This is a Google Earth snippet, a little image taken from Google Earth. And Highway 97 at the top, there's a couple of roads there's one on the left, one on the right. You can see over here, there's a water body. So I'm gonna now show you what happens when you strip off the forest, you strip off all the vegetation. This is what you end up with. It's a metallic, if you will, image. It's just a reflection, a three-dimensional reflection, but you can enter this in a computer and you can rotate it in three-dimensional space. You can look at this as you would from an aircraft, and you begin to see things that you couldn't possibly see in that satellite image. I'm just going to go back. So you get some vague feelings for the landforms there. But in LiDAR, what you can see is this huge old abandoned channel. This is a very large ice age channel that was conveying meltwater from the dying glaciers in central British Columbia. You can see this lineation on these hills. This is the footprint of the ice sheet. It's what we call glacial streamline forms that were carved into the ground by the overriding ice sheet. And you can see here these kind of funny arcuate, they're ridges actually. These are what we call eskers, which are bodies of gravel that formed in channels at the base of the ice sheet. We're looking at almost a perfectly preserved little snippet of what this landscape looked like as the ice sheet disappeared 12,000 years ago, 11 or 12,000 years ago. And as a geomorphologist, I look at this and say, oh my gosh, I'm in hog heaven here. This is really cool because you don't have to worry about, you know, all this obscuring vegetation. So now I'm going to return to the story, but I'm going to come back occasionally with LiDAR images to show you how we go about interpreting this flood landscape that we understand now. And so my story sort of begins at the end of the last ice age. Another thing that is totally remarkable, that it's just unbelievable. It's why I got involved in geology, is because this mentor of mine in university told me that much of northern North America was covered by ice sheets as little as 15,000 years ago. Now, I know 15,000 years ago seems like a long time, but in the total history of the Earth, which is 4.6 billion years, it's like yesterday. And yesterday, 15,000 years ago, there were 3 ice sheets that were covering Canada. There was a small ice sheet in the north called the Inuitian ice sheet, which formed on the Arctic islands, the northern Arctic islands. There was this monster to the east of us called the Laurentide ice sheet, the biggest ice sheet on Earth during the ice ages, covered almost all of Canada. But then we held up our part in the west with another ice sheet that we call the Cordilleran ice sheet. And on this image, it doesn't look like much, but it actually is well over 1,000 kilometers in length and more than 500 kilometers wide. And that ice sheet, the Cordilleran ice sheet, basically was up to 3 kilometers, more than almost 2 miles thick in places. It extended across the entire interior. At its peak, it joined on the Laurentide ice sheet over the westernmost interior plains. So up around Fort St. John, in that area would have been the juncture of these 2 ice sheets. And then on the west, it extended out onto the continental shelf, which at that time was exposed because the ocean was lowered by all the ice that was locked up on land. All that seawater was locked up on land, and and the edge of British Columbia extended well out into the Pacific, particularly in areas like Queen Charlotte Sound. So this ice sheet terminated essentially at the margin of the Pacific Ocean at its maximum. And on the south, and I want to point this out because I'm going to be talking a little bit about this, the ice streamed down into the northwestern US, so into Washington State, into Puget Sound, onto the Columbia Plateau, and to the east into Idaho and Montana. So they're remarkable, and this was not that long ago. And so the interior British Columbia might have looked something like this, which is actually Antarctica today, but I like to use it as an analog for what British Columbia would have looked like really just before humans actually arrived on the scene in British Columbia. So this story really has 2 chapters, and I want to kind of, preface my comments on this mega flood in British Columbia by talking a little bit about Lake Missoula. Now, you may know some of this story, but it is part of this ice sheet story. So when the ice sheet reached its maximum extent, it actually formed a lake, a big glacial lake that drained catastrophically a large number of times. And this is, I guess he's one of my heroes. I like his funky little cap here. Is J. Harlan Bretz. Now, he was a school teacher around the turn of the 20th century. So the first decade or two of the 20th century, he was a school teacher, secondary school teacher in Washington State. But he spent his summers to the east of the Cascades on what we call the Columbia Plateau. And it's this area that's outlined with this red rectangle here. And he began to make some observations that really kind of greatly improved our understanding of how this plateau, what had happened on this plateau. So beginning around, I think about 1907, he published a series of papers on the features, the geomorphic or land surface features that he was observing. And I'm just going to show you some of the things that he observed. Now, this is a satellite image, which of course he would not have had access to at the time, but he observed what we call the channel scablands. These are basalts, flat-lying basalts that are very scabby. They have no soil on them. They look like they've been eroded. And when you look at the satellite image, you get the feeling that there's this reticulate pattern, drainage pattern that's formed on the plateau surface. This is a reasonably flat surface east of the Columbia River. The Columbia River swings around here, comes up into British Columbia right at the top of the image. But you can see that emanating from about this area, you see these incredible scabby basalts. And everything in between is fertile, what we call loose, windblown silt soils that support agriculture east of the Cascades. But the scablands, basically, you couldn't grow any crops on it. It's a scabby basalt surface. So he kind of observed that scabby surface. He saw things like Moses Coulee. Oh my gosh, that's a road there. That's not a stream. This looks like an abandoned river valley. And you can see these beautiful flat-lying basalts that have been dissected by some process. Now, he kind of said, well, what could possibly produce that erosion in an arid landscape like this? And then he observed dry falls. I mean, some of you probably have been to Dry Falls. This is a state park in Washington near the Grand Coulee Dam. And it looks like an abandoned Niagara Falls, doesn't it? You've got a big pool, what we call a plunge pool that this lake sits in here. And you've got this kind of eroded escarpment. The trouble is, this is no Niagara Falls, because Niagara Falls would be confined to only a small part of this. This falls, the Dry Falls, extends for 5 miles laterally. And, here we can see it, the scabby surface near Grand Coulee, these amphitheaters with the plunge pools. Our analog for this would be, these are plunge pools that are scoured by large volumes of water. Potholes Coulee, he described Potholes Coulee in one of his papers. This is, you can see these agricultural fields, which are developed on these silty soils, but then you get this scabland track where the silty soils have been eroded off. And again, you get these kind of amphitheater-like erosional forms with plunge pools at the bottom. And it steps down because this basalt is flat-lying, so it's been eroded at different levels. And then most remarkable in my mind is West Bar. Now, these look like ripple marks to you, don't they? But that is a house there, and that's circled in red. And these are cobbled gravels. So these are ripples on a massive scale. These are formed by flowing water, at least that's what J. Harlan Bretz argued. But, you can imagine the depth of water and the speed of the water that would actually produce those ripples flowing across the landscape in gravels. So he published these papers and, kind of concluded the obvious that there had been a huge flood across the Columbia Plateau sometime in the past. And he thought it was probably during the Ice Ages. The established geological community at the time totally dismissed him. They kind of refused to look at the evidence, and they dismissed him because they couldn't imagine a source for this amount of water. If you don't have a source for the water, forget about the physical evidence, it can't happen. And this is an interesting commentary on science, that people tend to be dismissive of physical evidence unless you have a mechanism that underpins it. And I can give you one other example of that, and that's plate tectonics. Because at about the time that J. Harlan Bretz was presenting evidence for these massive floods on the Columbia Plateau, others were arguing that the continents had split apart. And we're presenting some pretty obvious evidence, because if you look at the outline of the east coast of South America and the west coast of Africa, they are jigsaw fits, but nobody would believe these early 20th century geologists, because there was no mechanism for allowing continents to pull apart like that. Well, now we know there is. And interestingly, eventually J. Harlan Bretz was proven correct, because he, well, not he, but a USGS geologist by the name of Joseph Pardee, at a meeting that J. Harlan Bretz was talking at, turned to one of his colleagues and said, I know where the water came from. And it came from what we call glacial Lake Missoula, which is here shown in dark blue. And this was a lake that was impounded at the end of one of the lobes of the Cordilleran ice sheet, courtesy of British Columbia. We sent this lobe of ice called the Pend Oreille lobe south of the border. It blocked the Clark Fork River and impounded a huge lake in western Montana. That lake at its maximum held 2,500 cubic kilometers of water. Now, I know that's a meaningless number to you, but if you think about a cube 5 miles on a side, 5 miles high, 5 mile wide, 5 miles deep, that's the amount of water that was in this lake, all water. And this dam, of course, was unstable, being a glacier dam. So it failed, and all that water was released in this cataclysmic flood that actually flowed across the Columbia Plateau and formed those erosional marks. Well, now we know that there was not just one flood, but there were probably 100 of them during the last ice age. And so they collectively have produced this amazing landscape that we see today. And Joseph Pardee was aware that there was a lake in glacial Lake Missoula, because he was mapping around Missoula, Montana, and he could see the old beach lines of the lake high on the hillside. And this is an old archival photo. It just kind of, because the snow enhances the beach lines, shows you at Missoula, Montana, how deep that lake was. Here it's probably 100 meters deep, as little as 13 or 14,000 years ago. And so the water that escaped from glacial Lake Missoula coursed across the Columbia Plateau, and then it joined the Columbia River and flowed down the Columbia Gorge. It reached what is now Portland, Oregon here. It backed up into the Willamette Valley, about 100 kilometers, 60 miles or so, and then it flowed out to the Pacific Ocean. And this is a little cheeky, but this is what Portland would have looked like. This is Portland, Oregon. This is what Portland would have looked like during one of these Ice Age floods, totally flooded out. Of course, Portland wasn't there, but it gives you a sense for the scale of these floods. So kind of one thing takeaway from all this is the volumes of water are huge. And the actual discharges, the peak discharges of these floods exceed anything that we see on Earth today. So to just capture this, what I've done is I've plotted a bunch of floods from different sources. These ones on the far right in the dark blue are basically your modern day peak floods. So I've got the Amazon River there, the Yangtze River, and the vertical scale is what we call peak discharge. So this is a number of cubic meters per second that those floods are carrying. And you'll see, of course, that this is not a linear scale. So it's what we call a logarithmic scale, and jumps up by an order of a magnitude of 10 for what looks like a unit increase. So here we've got 100,000 cubic meters per second. That, by the way, is far in excess of anything that the Fraser River can produce during its peak floods. 1,000,000 cubic meters per second would be here, the value 1. 10 million cubic meters per second. So these Missoula flood, the peak flood, the biggest flood, was carrying about 15 million cubic meters per second. That's just an extreme value. The peak flood, the largest flood ever measured on the Amazon River, is only 1/10 of that in terms of size. That huge river has produced floodwaters with peak discharges less than 1/10 of that of the Missoula floods. And as I say, if we looked at the Fraser River, it would be right at the bottom. It would just be a line at the bottom of this, something of the order of tens of thousands of cubic meters per second. Significant, to humans, but these ice age floods were just huge in scale. And I'm going to comment a little later on, there probably were people who witnessed these, or at least may not have survived them, but there were people in the landscape at the time these floods occurred. So now I'm going to take you to the British Columbia megaflood. It's not quite as big as the Missoula floods, but it's very impressive. And this is the story that we've developed and finally published on. And I'm going to kind of present that story to you. So this is kind of a map, cartoon-like map of what British Columbia would have looked like at the peak, near the peak of the last ice age, about 17,000 years ago. The Cordilleran ice sheet on the west joined the Laurentide ice sheet on the east. There was a suture where the two ice sheets joined sort of east of the Rocky Mountains here. And that was the peak condition. So this would be the time that glacial Lake Missoula was active. However, the ice age ended, and that's a cool story as to why that happened. We went in a reasonably short period of geologic time from an ice age world into a world that we know today, where there's much, much less ice on the surface of the planet. So 15,000 years ago was a time these two ice sheets were separating. They were both thinning, but they were also pulling back on their margins, and a bunch of glacial lakes were beginning to develop in Alberta. And this process continued. So 14,000 years ago, the two ice sheets are now separate. There's a string, a necklace of glacial lakes between the two. 13,000 years ago, British Columbia is beginning to emerge from beneath that ice sheet. The areas, the little kind of ice-free areas, are highlands that were appearing above the ice sheet. The ice sheet had pulled back on the coast. This was a time when we think people were moving up and down the coast for the first time, and maybe the first entry into the Americas, although I rather doubt it. I think they were here long before the last glacial period. But that's a whole nother story too. So 13,000 years ago, and by 11,000 years ago, pretty much all of British Columbia was free of ice. So this critical period that I'm going to be talking about is between 13,000 years ago and 11,000 years ago. And I would add that the Laurentide ice sheet persisted for another 5,000 or 6,000 years in a diminished form, but it was a much, much larger body of ice, and it kind of was, took longer for it to disappear from Canada. So at that time, when sort of uplands were emerging, but there was still ice in valleys, dead ice, stagnant ice. Lakes developed in most of the interior valleys of British Columbia. And this is an analog. I mean, this is a modern glacial lake from north of Glacier Bay. This is actually in British Columbia. It's called Glacier Lake, Melbourne, but it's impounded by a glacier. And you can see that it's just chock-a-block full of big chunks of ice. And this is what our interior valleys looked like 12,000 years ago. Totally remarkable. Well, that's an analog for many of the valleys. And I'm going to show you one example. The South Thompson Valley, we know that this was a valley that experienced those conditions because we have bordering the South Thompson River, these thick glacial lake sediments, these silts, the white silts of the Thompson that were actually first described 150 years ago by George Dawson, who was the first director of the Geological Survey of Canada. These are eroded remnants of the lake sediments that formed in these dirty glacial lakes. So the South Thompson Valley was the site of one of these lakes, but perhaps the largest one, and the one that's a source of the megaflood that I'm going to talk about, is Glacial Lake Fraser. And it formed behind a glacier dam. Glacier Dam was down here just south of Williams Lake, and inundated much of the Fraser River Valley and its tributaries back into the Rocky Mountain Trench, all the way back to McBride, north to that area I just described, Summit Lake, and west of Vanderhoof. This lake at its maximum held about 20% of the water of Glacial Lake Missoula, so about 500 cubic kilometers of water. And of course, as the ice continued to melt, eventually that lake became unstable. So just to show you, here's my first return to LiDAR. This is a colored LiDAR image. It's a synthetic image, but it's near Prince George. The low-lying area, the blue area on the right is basically the developed part of Prince George, British Columbia. And then this upland area here, you can see these beautiful, the footprint of the glacier, of the ice sheet that flowed northeast across what is now Prince George. We call these drumlins. They're beautiful streamline forms. I just get excited every time I see them. But sort of ornamenting that are these red colored strand lines. These are glacial lake beaches, like the beaches that we saw at Missoula, Montana. And they define the margin of Glacial Lake Fraser. So a colleague of mine who worked for the Ministry of Forests is reconstructing the history of this lake all through central British Columbia. At any rate, eventually that dam became so unstable that the lake broke through it. And the floodwaters, it coursed all the way down the Fraser Valley, the narrow Fraser Valley, all the way down to Hope and west through Bellingham and Vancouver. And I'm going to show you some of that evidence in the time I have. And I just add that before I tweaked on this flood story, I kind of would pass this exposure. Many of you will have seen it it's just south of Lytton, British Columbia on the Trans-Canada. And you're looking across the Fraser River. Here's the rail line at the base of the exposure, a beautiful exposure. And I kept looking at this, and as a geologist, this looked totally bizarre to me, these flat-lying beds with boulders sort of kind of punctuating sandy deposits. And I kept thinking, you know, this is weird. You don't normally see this type of thing. But it was only when we got LiDAR that I really tweaked on the fact that these are flood deposits. So there was a flood that deposited these inclined beds up to well over 100 meters above the present river level. So these floodwaters were 100 meters deep probably at this site just south of Lytton. And the reason I know that now is that I can see as a geomorphologist what we call whale backs. These are these features that look like the back of an orca. They're gently dipping streamline forms that are very characteristic of flood landforms. And I have to make the distinction between a whaleback and a normal river terrace. river terraces are flat. Basically, they're flat or so gently inclined that they follow the profile of the river that cut down through them and form them over geologic time. So here we have, in the upper part of this image, a series of 3 terraces in the modern floodplain. And the river over time has cut down through the fill and formed those terraces at successively lower levels. Below is a whaleback. This is much steeper. It has an incline form on really all sides. It's nestled up against the mountain here at Yale, but it's gently, well, it dips off towards Highway 1 as it approaches Yale. And it's inclined down the valley steeper than a fluvial terrace would. So as a geologist, I recognized immediately when I saw this LiDAR, this is a flood bar. And imagine if you're traveling through Yale that 60 meters above you, you had floodwaters, wall to wall across the entire valley. That gives you a sense of the scale of the flood that passed down this valley. And here's another image showing some of these flood sculpted features. These are not glacial features. These are actually flood sculpted features near Pavilion, north of Lillooet, where the Fraser River has cut a deep canyon through these features. And here is a boulder with someone for scale to give you a sense for the size of the clasts that were rolled along at the base of this flood. And here's scale of 2 meters, some of the clasts that were transported in this massive flood bed at the base of this column of water. And turns out that we've documented, probably close to 200 of these types of features between Williams Lake and Hope. Another feature, it's not as spectacular as the West Bar ripples or mega ripples, but this is an example of the same thing, where the floodwaters were sculpting a terrace and creating ripple marks beneath a column of water that was probably 30, 40, 50 meters deep, and carrying boulders up to a meter across. Again, kind of just, I'm giving you a sense for the types of evidence we see. And again, down at Yale, this beautiful whaleback ridge. And then on the other side of the river, you find less kind of not quite as nice whaleback, but this undulatory ridge that has boulders. Some of those little dark gray things are actually boulders that were carried by the floodwaters. And this is a type of material you find on these whaleback ridges, big, big boulders. Gives you a sense for, you can imagine what sort of water depths and velocities are required to move material like that. It's not trivial. And then one exposure that's very rarely exposed, but it's a kind of a sand pit or a gravel pit west of Hope, near Hunter Creek. And normally it's not in operation, but I happened to be there one time when it was, and I could see these dipping flood beds up to 40 meters above sea level. And the Fraser River here, and this is a kind of where they're mining this terrace of these flood deposits, nestled in behind a rock ridge. And the floodwaters here to reach the top of this terrace would have to be 40 meters deep, because that's 40 meters above the Fraser River, wall to wall. And you know that the Fraser Valley in there is quite wide. So it gives you a sense for how big the flood was when it entered the Fraser lowland at Chilliwack. And then finally, the last little snippet I want to show you, and again, I'm going to come back to the LiDAR, because I was aware of this kind of just west of Fort Langley. Fort Langley would be just off the right of the screen here in this area. You can vaguely see these lineations in the topography. These lineations are developed on marine sediments that we've dated to the end of the last glaciation. So we know that erosion that kind of produced that kind of landscape in there post-dated these marine sediments. So, and we've subsequently been able to date it to the to about 11,500 years ago. But this again is it's a satellite image. It doesn't really show you the features. If you stripping off the vegetation, you can actually see a little more what these features look like. So here's that same terrain. I'm just going to toggle back. Basically the same terrain in here. Fort Langley is located here. This is a drop off. So Fort Langley actually sits in an old channel of the Fraser River, which is much younger. So this is a remnant of this flood terrain. The floodwaters have sculpted out these marine clays and produced this lineation in the landscape. So this is a kind of a relic of the flood that probably coursed across this area for a week or two at the end of the last glaciation 11,500 years ago. It's not the only one. There's another tract of this land at Linden, Washington, just south of the border. So here we are, the top of this image on the lower right is the border. And here's another one of these tracts. And it's interesting, the floodwaters followed the low spots in the terrain in here. So the Fort Langley terrain is nestled down into this low part of the terrain, and the Linden one is nestled down into the lowest part of the terrain. So the floodwaters were divided in here. They went around Sumas Mountain. Part of the flood flowed right across Metro Vancouver into the into the Salish Sea, and part of it flowed into Bellingham Bay along the Nooksack River. So what are the implications for this as far as, it's a bit of an eye-opener because we kind of didn't understand that this catastrophic event might have played a major role in forming some of the features that we're well aware of in the Metro Vancouver area. Because when this flood occurred, it basically transported humongous amounts of sediment into the Salish Sea. And this diagram here shows at the time of the flood, there was no Fraser River Delta, or it was just forming. The dates here are a little off because this is quite an old image, but the Fraser River would have been flowing out into the Salish Sea. 5,000 years ago, the Fraser River Delta was partially formed, this yellow area, and today, of course, it extends west to its present margin and south to the Tsawwassen uplands, and it sort of extends to the margin of Boundary Bay. But we hadn't appreciated really that this the platform on which the Fraser Delta formed might have been partially created by this flood, transporting tremendous amounts of silt, sand, and clay into the Strait of Georgia and dumping it at the mouth of what the river was at that time. So I think that's basically the story I wanted to present to you. I'm happy to take this anywhere you like to kind of answer any questions you might have. It's just a snippet of this story. And geologists are kind of, I would say that geologists have long argued whether what we see in the landscape is a product of slow processes operating very slowly at rates that we can see them operating today, or whether in fact the landscape is a product of catastrophic events such as these megafloods. And so for really better part of 200 years, there have been two schools of thought. There's the catastrophism school that believes that much of what we see is a product of rare events, but events that do happen. And a classic example of one that much farther back in time would be the asteroid impact at the end of the Cretaceous that reset, evolution. And the other school is the uniformitarian school. And I grew up in that school, that basically what we see, our landscape, the features in the Metro Vancouver area, are a product of very slow processes operating over very long periods of time. And geologists can do that because they got a lot of time to work with. I mean, the Earth is 4.6 billion years old. So, you know, clearly a lot happens gradually, but periodically you get these rare events. It may be an asteroid impact. It might be a mega flood, such as a Missoula flood, that actually kind of radically changes the surface as we see it and gets preserved in the surface. So that whole Columbia Plateau surface is a really kind of a relic that's been preserved for 15,000 years or so. Changed, of course, because people have occupied and modified it, but you can still see the evidence of events, catastrophic events that occurred quite some time ago. So with that, if anyone has a question, I'm happy to take them.
Brian, did you want to say something?
Yeah, John, if you just want to stop sharing, that would be fabulous. Thank you.
Yeah. Let me do that. Stop sharing. There we go.
So I don't have any questions in the chat. And I don't, Brian, did you want to, are you able to unmute everybody, or can you do that all at once?
I can do that all at once.
I have a question.
Okay, Elaine.
John, I'm wondering if you can comment on the geologic history of Sumos Lake.
Sumos Lake.
Yeah.
Yeah, that's a good question. Sumos Lake, of course, persisted until it was drained, I think around 1930 or 1935. And it occupied the ground between what was then the Fraser River, sort of on the east, and Sumos Mountain on the north. And it kind of extended up to the border near Sumos, Washington. And it was, you know, a long, persistent post-glacial lake. We know from drilling that's been done on the former bed of that lake that there are lake sediments that extend, actually, they look like they extend below sea level. There hasn't been enough work. This was a master's thesis that was done at SFU about 25 years ago by Valerie Cameron, who documented the results of the drilling that they did around Sumos and really all through that lake area. Well, the lake that existed historically was really the remnant, the very shallow remnant of a much deeper lake that existed for thousands and thousands of years. And it's a bit of a problem in that that's very low. You know, the Sumos plain in there is I think less than about 10, 15 meters above sea level. So if you kind of have a lake in there that extends down below sea level, you have to have some barriers that kind of preserve it as almost a closed basin. Now there are barriers because there's Fraser River, or really the Chilliwack River, built a very large fan across the valley at would be the northeast end of Sumos Lake. It's a low gradient fan. The Vetter Crossing and Sardis are located on that fan. And it would have formed the margin of this lake. And it would have persisted right back through thousands of years. And then the Nooksack River on the kind of the south end of Sumos Lake also built a fan right across the border. So there was a kind of a way of keeping the sea out, if you will, of that area, but it's still that basin during late glacial time was actually had a floor well below sea level. Not to say you can't have that, because a lot of the fjords in British Columbia have been eroded by glacier ice to tremendous depths. Some of the fjords, I think it was, I'm not sure it's Butte Inlet, probably Butte Inlet, actually has been eroded in rock to depths of 600, almost 700 meters below sea level. Glaciers can be potent agents of erosion.
So John, on
question.
with Sumos Lake, what's on that site now?
Sort of what?
What's on the site of the old Sumos Lake? What's on that site now?
It was drained to create agricultural land.
Okay.
You know, so you basically, all that's is essentially farmland. It's getting a little bit encroached on, but they're trying to keep people off that agricultural land and up on the margins of the valley. Up, you probably, if you drive up that way, you've seen new developments appearing on the side of Sumas Mountain, and there's some, you know, on the rising slope opposite too. So it's essentially very fertile farmland, and the lake was drained for that purpose. You know, if that lake existed today, I don't think it would drain it because it had environmental consequences. That was a very, very important wetland, will, for migratory waterfowl, highly valued by the Stolo people. Another example of, you know, them not being kind of consulted in some of the developments that took place 100 years ago.
Okay, Victoria's got a question.
Thank you, John. Yeah, really fascinating talk. I think I don't know whether you said it or not, but how long did this flood in the Fraser, from the glacial lake Fraser, last? Is it thought? I mean, how would you even know? How would you be able to tell?
It's very hard to tell. We haven't actually done. You can numerically model the failure of the dam. The dam itself was a very broad dam. I didn't really say much about that, but it blocked the Fraser River from north of what is called Big Bar, almost to Williams Lake. So that's a better part of 100 kilometers. That dam was present when we think of it, when the lake began to drain. Typically what happens it's a kind of a positive feedback system. The dam begins to leak. It leaks faster and faster and faster. The discharges accelerate. Maybe the dam gets washed out and you have this full flush of water down the valley. We think it's a bit of a kind of a back of the envelope calculation that it would last about a week, maybe a little longer. And the peak of the flood would have been pretty short, a day or two. You know, so it would have built up and reached a crescendo. And then when the water had totally drained out, the lake was empty. It just fell back. So it's kind of, that's the thing with these big outburst floods. I commented that the discharges are upscale. You don't see discharges on Earth as big as this today under our present day landscape, but they're short-lived. You know, they don't last very long, but they do a lot of work in the very short period of time that they actually are coming across the landscape. And I meant to add that, and it's fascinating to me, but some of the work that's being done on the Central Coast, the archaeological work, is documenting the presence of people at about the time this flood occurred. So on Calvert Island, there were people about 11,500, maybe even before that, years ago. And we're finding evidence now from Washington and Oregon for people who were here before that flood. You know, so I kind of think there were people in the Metro Vancouver area at the time this flood occurred. I don't think we'll know that for sure, but you know, kind of if I were a fly on the wall, I'd love to see it.
I am.
Steve Smith has got a question.
Yeah, thanks. Thanks, John. It's just fascinating. Those LiDAR images are breathtaking, really amazing. Having had this interest in the Missoula flood for some time, I know two of the sort of telltale signs are these potholes that are sort of drilled into the ground by the hydraulic forces of the water.
Yeah.
And then also ice rafted erratics.
Yeah.
I'm wondering if in the BC story we've seen evidence of either of those yet.
We do. We don't see quite that same evidence, and you know, essentially the landscape across which this lake flows difference in the Columbia Plateau. We don't have the flatline basalts that the Missoula floods
Right.
rivers to kind of create the spectacular erosional forms. So we don't really have that type of evidence. We do, I didn't point it out, but just east of Yale, in that one LiDAR image I showed you where that kind of undulatory flood surface, down in a channel, there's a depression, a closed depression, and I think that's a kettle hole. There was basically a block of ice that was stranded from the dam. It was transported 200 kilometers to the south and got stranded right there, partially buried in the flood deposits, and then the ice melted out and produced a kettle. I've always been a little cautious about it because, you know, I know that humans can do strange things too, and there was a lot of placer mining in the Yale area around the middle of the 1800s. And I kind of kept asking myself, would they have possibly done something like that, created a big hole by, you know, placer mining? I don't think so. I'm pretty comfortable they don't, but, you know, I'm always a little cautious. Humans can do some very interesting things. And you can see some amazing placer workings along the Fraser River too. Placer gold kind of reworked gravels.
So Vlad had a question.
I would just like to add maybe something to what John was saying earlier on about the big rocks coming down, breaking up the glaciers and so forth. When I used to kayak on Chilliwack River, in one time was a bunch of us in flood waters where even trees with roots attached were coming down the river and so forth. And then occasionally you could hear a big, huge boulder underneath turning and twisting as the flow was so powerful. And then in the summertime, we were going back when the water was almost non-existent, you know, very little water. And there was one rock like that in the middle of the channel where most of the flow would go through. That was almost as big as the school was.
Yeah.
Really, really huge, you know.
Yeah.
To turn and twist something like that size around, it's you know, it's amazing.
Yeah, there are. We've just started this. We did publish a paper documenting the physical evidence, but there's a lot more that can be done. You can actually model these bars, you know, and the caliber of the boulders on the bars to get a sense for how rapidly the water was flowing and what sort of flow depths there were. So we can kind of refine that story. But kind of what really impressed me were these two flood tracks at Linden and Fort Langley, because they told me that, you know, you had huge depth of water in there, you know, probably tens of meters as flowing across that surface to scour out what is a sticky clay almost and create those elongate ridges. You need a lot of water to do that. So even at the end of the flood path, you know, you still had significant depths of water. And, you know, I mean, we'll never see that again. It's a relic of a kind of a landscape that existed in the past. But it certainly is, you know, orders of magnitude larger than the 1948 Fraser River flood, for example, or the biggest flood of record on the Fraser was 1894. Big flood, caused a lot of damage, but it was a pretty tiny little thing compared to what we've documented. Obviously, you can tell I love catastrophic events. That's probably why I'm so big on big earthquakes too.
So we've got a question from chat, and I think you already answered part of it, but from Jeff says, where are some places you could find evidence of Fraser Lake? And I assume that he's not talking about Fraser Lake, sort of west of Prince George, but.
Well, it's tricky because again, you know, we base this reconstruction on LiDAR imagery. But having said that, you know, around Prince George, you can see some of the sediments that have accumulated in those lakes. And and they're very much like the South Thompson silts. They're beautifully layered. Sometimes they're regularly layered. They're what we call varred, beautiful repetitive kind of layering in clays and silts. And so you get road cuts around Prince George that expose those. The beaches, you can't really see them on the ground. They're too indistinct. You can only see them in this bare earth. Well, you can see them in aerial photographs, but they're really most striking in this bare earth imagery, this LiDAR imagery. But there are places, I mean, there's been so much development in the Prince George area that it's hard to direct you to a place where you might see them. But there are gravels, these kind of pea gravels, these beautiful, well-sorted kind of rounded gravels that are beach gravels that are associated with the beaches that existed in the Prince George area. So the Glacial Lake Fraser, if you're alert, road cuts will pick up on these beautifully layered clays and silts that settled out in Glacial Lake while it existed for the short period of time it existed. But I would actually, there's some much better exposure to those types of sediments around Kamloops. You get these beautiful exposures along the riverbanks of the South Thompson. So, you can kind of get a better look at what glacial lake sediments look like in the South Thompson Valley and in Fraser River Valley.
Okay, I've got just one more question here from the chat. Do you think that the Megaflood caused platform under the present day Fraser Delta further cause for concern?
Okay, well, that's a good question. The thing is, of course, the entire Fraser Delta is built of loose silts and sands and some clays. So I would say, kind of those soils, if you want, or those sediments are a source of concern. They're known to be liquefiable. But beneath the surface, really post-glacial sediments, you've got this big sheet of loose sediment, and it hasn't been recognized as such. So I don't think we know yet what implications that has for engineering. And certainly some of the big projects that are going on now, such as the new water lines that are being placed beneath the Fraser River to supply the growing demand in Surrey and Delta, where much of the growth, the population growth in Metro Vancouver is, go to those depths. I'm involved in kind of providing the geologic models for some of those deeper excavations, and I've got this on my mind now, as to what kind of geotechnical implications that sheet of rapidly deposited sediment might have. But I'm kind of beating around the bush a bit because I don't really know. We don't have really much data at those depths below the sort of post-glacial delta surface.
Okay. So Victoria, did you want to?
Sure, yeah. Well, John, the word fascinating has cropped up a couple of times in the questions to you, because really that's the word that the only word we can use to describe your talk, which was so clear. Loved your slides too, and you tell a really, really good story. So thank you so much for taking the time to spend.
It's a pleasure, and I hope each and every one of you is well and stays well. We will get out of this messy world. I hope I've been a diversion for an hour. Constant worry about the virus, and I'm kind of, I just wish you all the best in getting through this.
Well, compared to a mega flood, the pandemic is nothing. So you always come and scare us anyway. I mean, we're used to this earthquakes and landslides. So.
Well, thank you very much for inviting me, Victoria.
Thank you so very much, John. And so yes, everybody's clapping away, and there's some very complimentary comments in the
Yes.
chat as
Yes,
well.
excellent presentation. Yeah,
Yes.
so exactly. So,
Yeah.
great.
So we're going to move on to the wildlife sightings bit now, John. If you want to slip away, or you can stay here. It's
Because I still have dinner to do here.
Okay,
yes, yes. Well, thank you again very, very much.
Thank you.
great. Thanks, John.
Yeah.
Okay, so we'll move on to the wildlife sightings. And since we do have approximately 40 photos, maybe we should get to that first, Brian? Or
Okay,
you, or,
no problem. I'm just readying myself right now.
okay, or does someone have maybe go with one wildlife sighting to start with if somebody has got something of interest? Susan, you sort of got your hand up, but not.
I do.
Okay, Susan.
It's Nora.
Oh, sir. Okay, Nora, sure. Yeah.
Well, I had a very exciting wildlife sighting. I was watching two male flickers out my kitchen window, and I was trying to get a photo of them, and they started doing what I assume is a courtship display with head bobbing and tail wagging. And I was surprised because it was two males, and they were, maybe just 2 feet apart, sitting together, and then they would sit absolutely still, and then they'd do the whole head bobbing and stuff. Then a little later, a female came in. They didn't do anything. Off she left. Then a little bit later, a second female came in the tree beside, and the two females did head bobbing and tail wagging. And so one tree has two males doing it, one tree has two females doing it. And then finally, one of the males went over to the females, and he did a little tail fan display, which was very impressive. I thought he was very handsome. So I've never seen that before, but now I have. My suet is going down drastically because I have 4 flickers coming to the suet basket.
Great. Yeah, I had 2 flickers on the power line across from where I am, and I was hoping they were going to do the dance what I've heard before, but they didn't. They ended up just flying away. So
I was excited because I got a little video of it.
oh, great.
It's I don't know why, but anyway.
Great.
Maybe we can have it as part of the wildlife sightings.
Yeah.
So, yeah.
Oh,
So Brian, are you ready to go?
I'm ready to go. I'll start sharing my screen. Okay. Can everybody see my screen?
Yes.
Okay. Fabulous. Okay, so here we go. And I that was a bit of a tease. I've taken some literary license here, and I'm selfishly having my own couple of slides first. So please forgive my indulgence. Okay, so we've had 2 new wild creatures invade our home, and these are them.
Oh, lovely.
Jealous.
Willow, these photos are about 7.5 months old. They're at 7.5 months old. They're 9.5 months old now, but Willow is a female. Jetson is a male. So we got them from VOCRA, the Vancouver Orphan Kitten Rescue Association, and they're just fabulous. They're hilarious. They're actually siblings. They're brother and sister. So we got them together, and yeah, they're just hilarious. Absolutely hilarious.
Lucky you.
Yeah, and this is sort of like a wildlife sighting. This is one of our hummingbirds sitting on a little swing below the feeder, and this is Mr. Jetson. They both love watching the hummingbirds through the sliding glass door. They don't go outside, of course, but they do enjoy watching the hummingbirds. So, yeah, that's my wildlife sighting. So, and on to the next. This is also mine. And I was out there the other day photographing hummingbirds, and I lucked in, if you might call that, with
My goodness.
talk about timing. I could not have planned this if I'd tried. He was obviously doing his business just before having a feed.
I missed that.
Absolutely
Great
amazing
title.
timing. Just total fluke.
I
Anyway.
didn't know this was X-rated.
Yeah. So yeah, timing, absolute fluke. So anyway, on with the real show. Okay. Kristen Evelyn
Wow.
is I saw Evelyn log on.
I didn't see her personally, but
Okay,
could have been.
I saw the name log on. So this is from Kristen Evelyn Thompson, and you can. There we go. Sorry. Sorry.
Oh, my.
If I had.
Oh.
So, okay. So on to the next. Vladimir.
Yeah, this is one of my images from Colony Farm, 2020 in the spring. I thought I'll put that one in after the swallow lady was doing the presentation.
Mm.
So,
Nice.
We'll have to rush through these pretty quick because we've got lots and lots and lots. If anyone can identify that, please speak up.
Where is?
It's a barn swallow. Isn't it?
There you
Oh, my.
go.
Wow.
And that one, it's the famous one at Burnaby Lake this year, February 27th.
He's still courting the lady.
Here's the season.
And this one here, I'm not too sure of the name of it. That's why I didn't put it down. It was also down at Blackish Pit, but it's one of the yellow legs. But I'm always confused. Is that the long yellow legs or the short yellow legs?
Greater.
Which
Greater
one?
yellow legs. Greater yellow legs, isn't it?
Yeah. And I think there's 3 more. Oh, and this image I put in, if you want to test your camera, how good it is for tracking. When you're following a bunch of, in this case, geese, right? When you go behind the trees, if your camera switches over focus to the trees, that means you probably should take it back to the store and get another one.
Oh,
It's if you want to shoot stuff like that, it's very important that you have a camera that will track even when they fly in behind the trees, right? That's why I put it in to show just the possibility that can happen.
Great bird.
I think I got 2 more. These were just taking off, also down at Blakemore Lagoons. And I think one more last one.
There we go.
beautiful.
Regent.
Yeah.
Thank you.
Gorgeous.
Oh,
Evelyn Thompson.
Oh, the little
Still not.
favorite little bird. Oh, with little red spot. Well done.
Beautiful.
Wow.
Who's the photographer?
Chris and Evelyn Thompson.
Another one from Chris and Evelyn.
nice.
Little muskrat.
Can you guys see the detail at the top of the screen? Because I
Okay.
The
Yes.
text, yes.
Yeah. Yeah.
Yeah.
Yeah.
Right. Okay.
Yeah.
Wow.
What I like about
Susan.
the little ruby crown on the top of that is it's very breezy, and you can see it's being blown in the wind.
Yeah.
Yeah.
Wow.
Oh, wow.
Even its feathers on the right side that we're looking at it, they're being pushed up.
Wow.
Beautiful.
Aw,
Nuthatches are always precious.
yes,
One of my favorite birds, yeah.
they are so sweet.
Well,
Ah.
it's just such a beautiful sunny day in March, and the lighting on that buffalo head was just so beautiful.
Amazing the different colors.
Yeah.
Yeah, good pick.
Those birds are one of the most difficult one to expose because if it's sunny, well, you have so much white, and then the darker colors, it's very, very hard to get them.
Yeah.
So they both look okay.
Oh, nice.
Yeah.
Kingfishers pose so beautifully. They're easy to get photos of.
Much like my cat.
Oh, and this heron, it was poking in the dirt, in the mud. Do you see its muddy bill? I don't know what it was getting in the mud.
That's unusual.
Oh, there's a dipper.
Oh,
Yeah.
there's the dipper. I've been on several walks with Susan, and the only thing I've ever seen is dipper poo. I've yet to see a dipper.
How do you recognize that?
If you go up the river a bit further, you get dippers.
Yeah.
Oh, right.
Oh, our chin.
They come around my garden after my birds that are at the feeders, unfortunately for them anyway, but it's nice to see the hawks too.
Oh,
Yeah.
handsome.
Diane.
All the nest.
Oh, wow.
Nice.
Yeah, the heronry, that shoreline trail. Oh, really?
Oh, and the handsome pair.
Ah.
I told you what they were, but I've forgotten.
Hooded mergansers.
Thank you. And I was just up Scott's Tree. It says it there, and I'm afraid I just have my phone, so that's all I use to take pictures. It's exciting to see those two.
Wow.
Oh.
It looked like it was admiring its flesh.
Oh, that's all.
Beautiful.
Oh, and I had my red crossbills, and a whole flock of them landed in my bird bath. They were there probably less than 2 minutes, so I was so lucky to see them.
That's amazing.
And I think the next one shows the
Yep.
up.
The next one's beauty.
Wow.
Oh.
Wow.
Good one.
Yeah, good one. See one
Wow.
northeast. Wow.
Amazing.
Beautiful.
Diane.
Yeah, that was the coot, American coot at Lake Burn Lagoon.
Oh my goodness. Okay.
That's mine, right?
Yeah.
Oh, yeah, probably.
Yes, Paul.
Yeah, you can go through these quite rapidly. Just some shots. This is Lake Lagoon. This is
Wow.
male and a green wing teal.
Wow.
Colony farm.
That is in focus. Holy
Is
goodness.
it
The
ever?
pattern on its swing is amazing.
A colony farm having a scratch. A hooded merganser, of course.
Good action shot.
The water's lovely.
Oh, yes.
And a merlin at Blakeburn. Yeah.
Wow. Wow.
Very small bird. Look at this. Colony farm.
Huh?
Ringneck duck. Blakeburn.
Wow. Huh?
Oh.
You get a few river otters there once in a while. Another wood duck at Colony Farm.
Oh,
I like the water.
Yeah.
Oh, yeah. Magic.
Must have been taken in the afternoon, maybe, with the reflection.
No, just vegetation. So this is in
Okay.
mine now.
Okay.
The ruddy duck.
Is Ellen on this tonight? No.
Really?
That's at Burnaby Lake.
Okay.
Oh,
This
It's the same bird, just two different photos from different angles.
He's got a fish or something.
Yeah, he's got a fish.
wow.
What is he swallowing? Is that a salamander?
Sure. It's hard to tell.
Fish.
But it looks tasty.
Fish.
Yeah.
It's swallowing the fish.
well, we've got a picture like
Oh,
that. Oh, that's excellent.
That's a great action shot. Oh my God.
Wow.
Incoming.
Yeah.
Through the runway.
There's the cinnamon.
Oh, nice.
Oh,
Oh, he's cute.
was slate colored.
Yes. Yeah, that's
Oh,
Yeah, that
what
was what it actually was. It's through email.
A Cassiar? Was it a Cassiar, Junko?
That was the final resolution.
So can I just interject here?
Yeah.
Please.
The resolution has been refuted.
Oh, okay.
This is back to being a slate colored.
It's slate
Junko.
colored. Yeah.
Yeah.
Okay. Okay.
Juncos, turns out, are really complicated. So yeah, Ron Long or Lee Harding has been doing a lot of research since our last get together.
Okay.
Oh,
wow.
Quite the controversy.
Yes.
Okay, and that's it. I forgot to delete my template slide. So thank you all. That was fabulous. We got to those pretty quickly. But there's some fabulous photos.
Wonderful photos.
I really want to thank everybody for sending in all the photos. It's getting really, really good and really successful. So, and I'm hoping everybody's enjoying the photos. I love putting them together. It really is quite fun, and I enjoy seeing them all before everyone else. So, yeah. So thank you all. Send your photos to me via that email, berkmountainats@gmail.com, and we'll you get your 15 seconds of fame next meeting. Thank you.
Great.
That was fabulous.
Yeah.
Thank you very much.
Thank you, Brian.
Yes.
Thank you.
Yeah.
thank you.
Yeah.
Thank you, Brian.
And
So,
all the photographers.
Yeah.
So we
Yeah.
so we are just after 9 o'clock. So I'll have the announcement. We've got our BMN show and share coming up on April 21st, and that'll be from 7 to 8 p.m. And the topic will be exploring the Bruce Peninsula in Ontario, and Diane Kitzik McDonald will be presenting. So that's going to be a great show and share. So there'll be a link sent out to that a couple of days before the meeting. So look for that. And I'll just turn it over to Victoria to bring it to a close.
Okay. Well, I will bring this meeting to a close then. Forthwith. Anyway, I think these things are going great. I wouldn't say we're victims of our own success, but it's really successful. All you people submitting your photographs, it's just absolutely wonderful. And we can actually zoom right through them. That went very smoothly, thanks to Brian, and very quickly too. So I look forward to seeing you all next Wednesday, the 21st. Have a good night. Bye for now.
Bye.
Bye, everybody.
Bye.
Thank you.